Welcome back. In this video, we're discussing constant opportunity cost PPC curves, and we're going to be seeing how the production possibility curves are drawn when the opportunity cost is constant. Now, first of all, remember that whenever the opportunity cost is constant and we're drawing a constant PPC, we have to draw it as a linear downward sloping straight line. So it's going to be a linear downward sloping straight line, just like I've drawn over here, and that is basically indicating that the slope is constant. Now we know that the slope of the production possibility curve is telling us the opportunity cost, because it's the slope is basically change in y over change in x, and change in y is representing the amount of good y that is actually foregone to produce an additional unit of good x. So basically, and that's why the slope is negative, and that negative slope is indicating the opportunity cost in terms of good y foregone to produce an additional unit of good x. So remember that the slope of the downward sloping linear line will be constant. The slope of a linear line is constant. In that sense, we draw a constant opportunity cost as a linear line, and this shows that the opportunity cost of producing each additional unit of good x stays the same each time, guys. Each time one additional unit of good x is produced, right? Which means that each time an additional unit of good x is made, the same amount of good y is foregone to produce that additional unit of good x as it was foregone to produce the additional previous unit of good x, right? So let's now see with some, with some calculation. So you have good x and good y on the x-axis, and point A is telling us that you're actually producing 90 units of good y with 10 units of good x, and point B is telling us that you're making 60 units of good y with 25 units of good x. So let's see what happens if you go from point A to B. So guys, if you move from point A to point B, let's see what happens here. That what's going to happen is that, let's say, at point, let's calculate the slope when you move from point A to point B. And the slope is basically, the slope is technically the marginal, or it is the marginal opportunity cost here, right? So if you move from point A to point B, you're actually foregoing 30 units of good y, right? You're foregoing 30 units of good y in order to produce how many units of good x? In order to produce 15 units of good x. So in order to produce 15 units of good x, you're foregoing 30 units of good y, right? So this means that the marginal opportunity cost should come to, that is, for each x, you're foregoing how many y? You're foregoing 2y, right? So it's simply telling us that for each x, for each additional x, you're foregoing 2 units of good y. That is, this happens when you move from point B to point C. And let's see what will happen if you move from point B. Sorry, this happens when you move from point A to B, and let's see what happens when you move from point B to point C. So the slope over here would still, you'll see that the slope here would be constant. That is, it would, be the same as 2. So if you move from point B to point C, how many additional units of good x have you made? The additional unit, that is a change in x. Change in x is how much? Change in x is again 40 minus 25, that is 15. And the change in y is again negative 30. So if you put that into this formula, the answer would be 30, again minus 30 over 15, again the answer is minus 2. This is simply telling us that the marginal opportunity cost, that is the opportunity cost of producing an additional unit of good x when you move from point B to C, is again 2 units of good y. And over here as well, the marginal opportunity cost to produce the previous additional unit of good x was still 2 units of good y when you move from A to B. So the point what we're trying to say over here is that this is telling us that the marginal opportunity cost stays constant as you go down the curve, because this is a linear line, and as you go down, the slope is constant. That is, the marginal opportunity cost stays the same, and that is how you draw a constant opportunity cost PPC curve. But the point is, that's how you'll tell the examiner that the opportunity cost is constant, but you also need to give the reasons why. So remember that when the opportunity cost is constant, this means that equal amounts of good y are foregone each time you produce good x. So each time you produce a unit of good x, you are always going to forego 2 units of good y, like you forego when you move from A to B and then B to C. So equal amounts of good y are foregone, which means, and the reason why this happens is that there is perfect substitutability. There is perfect factor substitutability of resources, perfect factor substitutability of resources and factors of production. It simply means, basically, guys, that your factors of production or your resources are uh, equally suited, and equally suitable, equally suited, equally substitutable, to produce good Y as they are to produce good X, and as they are to produce good X as they are to produce good Y. So your factors of production and resources are equally suited to produce good X and good Y. So there's perfect factor substitutability. There's perfect. You could also say that there's perfect factor mobility as well. Sort of, it's a, when you move your factors of production, when you substitute your factors of production from Y to X, so each time you produce more and more of good X, equal amounts of good Y will be foregone, because the resources are equally suited to producing both Y and X at in the same way exactly. So in that sense, each time you make an additional unit of X, so the same amount of good Y will be foregone each time you go down the production possibility curve. So that's it, guys. That's what talks about, constant opportunity cost, and that's all you need to know for constant opportunity cost. And yeah, that's about it. I'll see you all in the next video. Until then, take care.